Solve and show working for the following problem. Your patient's mammogram is positive for breast cancer, which has fairly low rate in your state of one case per 1,000 women annually. You know from the literature that the mammogram test has a sensitivity of around 92% and a specificity of 95% depending on the study. What do you tell your patient when she asks, do I have breast cancer? Show your work in both a contingency table and showing the shortcut based theorem.
The table we made is based on disease positive and test positive and disease negative and test negative. So we have a sensitivity of 92 and we know we have a population prevalence of 1/1,000. So our total, when we take that into decimals, 0.001 as a prevalence and multiply that by our sensitivity, which is 92%, we would get a positive test and a positive disease of 0.00092. With the remainder of that 1% 1/1,000 prevalence that would test negative, but still disease positive would be 0.0008. And then we have a sensitivity of 95%. So that would be our disease negative and test negative. And the remainder of our population, which would total to 0.999. And then that would multiply together, that would give us a value of 0.94905 as the disease negative and test negative, with the remainder being 0.04995.
So what is the probability that the patient has the disease and also has a positive test? This is also known as the positive predictive value. And to find this, we would take the total positives over the total positives plus the false positives. So that would be 0.00092 over 0.00092 plus 0.04995, giving us an answer of 0.018 or 1.8%.
As mentioned with the values above and shown in the contingency table, we will be solving for the positive predictive value. So the value of having the disease when also having a positive test. And as mentioned, that would be 0.00092 divided by the total positives, which is 0.05087, which equals 0.018 multiplied by 100 at 1.8%.
So continuing on, using the Bayes theorem, the shortcut version, I will now take those very values that my colleagues has just calculated and plug it in the formula highlighted on the sheet. Rate of disease times sensitivity over rate of disease times sensitivity plus rate of no disease times false positive rate. After having done that, a calculated value of 0.018 or 1.8% resulted. And essentially the interpretation of that will be there is a 1.8 chance of this person having the disease giving a positive test.